So thank you very much, Kung, for that warm introduction. I'm very, very grateful. So today's talk was motivated by a story that happened with us. We had put out a blog post about factuality and so on, and fortunately it got onto the front page of Hacker News. And then lots of comments in, you kind of see people who say this, they say it's always the same. They show one case study where LLMs work, open LLMs work, and I just end up going back to OpenAI and ChatGPT all the time. And so I really wanted to, there is this idea out there, at least some of the community, that LLM, especially open LLMs, are still somewhat toys that don't quite meet the characteristics of the existing products. So what we'll cover today is a little bit of a discussion about what are some examples of proprietary open LLMs. I'm going to give some examples from our own experience about people using LLMs in production. And then I'm going to talk a little bit about why people use open LLMs. And also, I want to be direct about it and tell you, there are certain areas where open LLMs are not as strong as the proprietary offerings. And it's really important to know where you stand. Okay, so I'm going to tell you a summary because there's a really good talk next door about like intellectual property and LLMs by my colleague Justin. But if you just want to know what I'm going to say, I'm going to just provide more detail and more evidence on these key points, right? And it's really about the viability and the pros and cons of each, and that they're radically cheaper. But it's also that I want to talk a little bit about the work and the evidence supporting this as we go on. So the first question is it viable in production? Well, the answer is yes. Right now, we have an Anyscale endpoint service that is available, and I will flash up a special offer at the end of this seminar to get you to stick around. But you can just go to app.endpoints.anyscale.com right now and set up an account to get an access to 4 different models, Llama 2 in the different sizes, and also Code Llama. And it's pretty cheap, and that's what we've spent a lot of time at Anyscale optimizing. So it costs somewhere between 50 cents per million tokens and $1 per million tokens, depending on the model. So let's start with some quotes from our customers. So we've been having this Anyscale endpoints, which serves open LLMs, running in preview mode for about a month. And we already have some commercial customers, Realchar and Merlin. I won't read the text, but the key things that come out is this kind of managed hosting of LLMs means you're not fighting infrastructure. It takes you a few hours to bring something up, and it's like super, super cost effective. And it allows Merlin in particular to stay cost effective for its millions of customers. So one other thing is that we use open LLMs in a production application. So this is the demo that Philip and Goku showed at yesterday's keynote. And basically what it is it's showing, I'll play it again, and I sped it up by 3 times. But you click on the Ask AI icon, you ask a question there, and it generates an answer about how to use Ray in seconds. And then it can even have links to documentation that have more details. You click on those links, it takes you to them. And that's running 95% plus on open source LLMs. And the 5% is something that we're going to talk about soon. So we're trusting our relationship with our customers to an open source LLM. And this gets hundreds, if not thousands of queries per day. And we're trusting it, even internally, we use this to generate code for our users. So let's talk a little bit about the different options that you have when you're using an LLM for inference. So you have the proprietary options like OpenAI and Anthropic. And then you have what you might call managed open LLMs. So that's things like Anyscale endpoints and Hugging Face and so on. And finally, the third option is self-hosted. So you download the LLM off Hugging Face and you serve it yourself. I've talked about this at other places. If you want to see what I say, it's, you can just follow that link. But the TLDR is it's doable, but probably more complicated than you think it is, and probably less cost effective than you think it is. Because when you're doing something like a managed open source offering, we get to aggregate across all of our customers. So we can offer it at a cheaper price. And the final thing is that we have a library called Aviary. And Aviary allows you to very easily deploy LLMs for self-hosted models. And it's built on top of Ray and RayServe and all the awesome features you've been hearing about for Ray. So let's just talk a bit, for those who are not aware, about the most popular open models. And you might ask, what are the quotes there for? And that's because there's been an argument about exactly what open is. None of the open quote models are really true open source models, in the sense that they give you a license to do whatever it is that you want. So for example, the Llama 2 license is saying, yeah, you can do anything you want, except you can't use us to train other models, and you can't use us if you're a business with more than 700 million daily active users, which there just happens to be like about 15 of those, most of whom are competitors for Meta. But then the funny thing is, Google is one of those companies, and Google has a license for Llama 2, and now you can get to go to Google and it will serve you a Llama 2 model. So they're even permissive with the license. Falcon is another great thing that, it used to be before Llama 2 came out, Falcon was like the most popular of the open models. And in fact, especially because I had an Apache license, but this is a very active area. And so just last week, they released a new model that was bigger, 180 billion parameters. And so people are very excited to get that until they noticed that there was something in the provision that says you're not allowed to offer a managed hosted version like Anyscale endpoints without talking to us first. So we have to get a license from them. My point is that this is a really, really dynamic space. Open models have been getting more plentiful and more capable. And I don't know of a time when one of these LLMs has been the most popular one for more than 2 months. So you have to basically keep your eye on the news to see what the latest thing is with open models. Yeah. So I want to take a moment to just share a concrete comparison that we did at Anyscale to check when is open better, when is proprietary better. So what we've seen is that when you try to do good summaries, almost anything can produce a readable summary that is concise and all of those types of things. But the one aspect that is really difficult for LLMs to get right is to be factually correct. So we chose to focus on that dimension of factual correctness. And you might say this isn't exactly summarizing, and I would say that's true. But it does capture the most tricky part for LLMs of doing these things. So the task we chose is one that's established in the NLP literature called summary ranking. So imagine I give you the sentence at the top about simmering tensions between the top statement. And then I ask you, is A a correct summary or B is a correct summary? What would you say? Well, unless you think people fit between Miliband's ears in his head, it's got to be the first one, right? So both of these were constructed by LLMs. Only one of these is the correct factual summary. So we ran this experiment across GPT 3.5, across Llama 2, and GPT-4, and also we had from the literature existing results. And what they showed is basically humans were at about 84%, and GPT-4 was slightly better than human, which could be just noise in the experiments because it's only 370 examples. But it's also possible. We have seen superhuman performance before from GPT-4. And then Llama 2 70B, the open model, was getting 83 or 82%, so just a little bit behind human, right? So you might say, well, the answer is obvious then. Let's go use GPT-4. And I wish it was that simple, because the thing is that you run these numbers and you look at how much it costs to actually use each of these LLMs, and you realize that if you wanted to use GPT-4 to summarize something like 100,000 words, it would cost you about $5.50 versus Llama 70 at our production prices would cost you about 20 cents. Now, GPT 3.5 Turbo is not that much more expensive, but the performance is nowhere near as good as Llama 70B. So there are particular data sets, and my personal, from like doing the math and everything, I suspect GPT 3.5 Turbo is about 30 million parameters. And my hypothesis is that's the biggest you can fit on an A100, but that's a complete guess. Nobody really knows. So if something is 70B, there's a chance it could actually be better at GPT 3.5 than GPT 3.5. So what I want to talk about a little is, it's very easy to kind of put up a slide and say 30 times, okay, I get it 30 times. But the thing is, you have to think about it from what products does this allow to exist and what products don't exist, right? So let's say we were looking at Rate Assistant, that application that you saw before, and assume that we get 2,000 tokens in and we give 500 tokens out. And you might be asking, where is the 2,000 tokens coming from? And that's because Rate Assistant is a retrieval augmented generation, a RAG application. So often the input going to these applications is large. And say we're trying to do 1,000 questions a day. Now, if you do this with GPT-4, it turns out that you're going to spend something like 10 cents per question. And over the span of a year, that's going to cost you $35,000. Whereas if you use something like Llama 70B, it's only going to cost you $900. And so the answer is like, one of them is good enough that, you know, if you have a permissive credit card policy at your company, one of them you could put at the credit card. The other one, you've got to run up the organizational chain and decide, is it worth $35,000 and do tenders and all of that kind of stuff, right? And maybe the manager say, no, we're not willing to spend $35,000. So it really materially affects the type of applications can exist. And that's why I'm excited about open models, because they allow applications to exist that would not otherwise be cost effective. So I'm going to talk a little bit about fine-tuning. I think, you know, if you've been attending the talks, you're going to hear fine-tuning and RAG everywhere. And this is just re-emphasizing the point that we had at the keynote yesterday, which is it's very possible for a sole fine-tuned open source model to outperform the best available general proprietary model in some cases, right? So this is the results from yesterday. Remember, we had Llama 2 7B on the natural language to SQL conversion task. And we also compared it to GPT-4. And you go, well, how does GPT-4 perform? And I am guessing, again, there's rumors, nobody really knows the truth, that GPT-4 is like 1.4 trillion parameters. It gets 78% accuracy. And then Llama 2, after you fine-tune it, gets 86% accuracy. So this model that is literally 1/200th the size and costs 15 cents per million tokens, once you've fine-tuned it, can outperform GPT-4, the best model that we know about so far. I want to issue a word of caution about fine-tuning, because I want us as a community to understand when to use fine-tuning and when to use other techniques. Because fine-tuning is not a silver bullet. And I think we get that impression sometimes. So I wanted to share an experiment that we did where we took an LLM and we tried to, our hypothesis was fine-tuning is great when it's about the format or the shape or the type of language you use or any of those types of things. But it's not about facts. And so here's a crazy experiment we did. We took the complete works of Shakespeare, and everywhere where it said Romeo, we replaced it with Bob. Because we wanted to see if the LLM would learn that, based on the data we'd given it, Bob was the one that was in love with Juliet, right? And sure enough, we put it in, we trained it. We even turned up the temperature all the way up to 0.9. And you can see on the right-hand side, not once did it generate Bob. So you do not use fine-tuning for facts. It just doesn't work. What do you do instead? You use retrieval augmented generation. And that's the other term that if you've been to any of the seminars, you've been hearing, right? So this is the architecture of the Ray assistant that you saw earlier. We take the query, we feed the query into the LLM, but we also go through this other chain that retrieves context and feeds it into the LLM. So the reason that RAG works is that because it's letting the vector DB do what it's good at, which is search results, and it's using the LLM for doing what it can, which is synthesis and generation. And thus it makes the problem easier and thus increases the chances of the LLM making it like a correct assumption or generating correct text, because it's just sorting through evidence instead of being asked to hallucinate. And for these types of tasks, Llama 70B works just as well as GPT-4. Both of them can do this task well. But if you just ask a question out of the blue, GPT-4 is going to do better than Llama 70B. But you give either of them the right information, and they will produce similar results. So you might think from this that I am like an open model dealer, cancel all of your OpenAI and ChatGPT subscriptions, never use them again, and just use open source models. That's not what I'm saying, and I want to be very clear about that. I really am a believer in having the right tool for the right job. The great thing about living in the world we live in is we have lots of different options, and that gives us more flexibility to solve the problems that our users need solved. And there's going to be 4 challenges that I'm going to talk about currently with using open source LLMs. And the first one is quality. The second one is instruction following, and then function templates and large context windows. So if you ask anyone who's been working with LLMs for a while, what is the best LLM out there? There's no doubt they will either say GPT-4, or if they're a little more nuanced, they might say Claude 2. They're not going to say Llama 270B. And that's logic, and they definitely have the best quality. And what you see is better analogical reasoning, better planning. So if you ask for a plan, probably GPT-4 will come up with a better result. The answers are more refined. And if you're asking for evaluation tasks that are very complicated, probably GPT-4 or Claude will perform well. But there are also areas where open LLMs are good enough. And I would say the two, and I'm working on a blog post about some of these options, but the two that I would point out is Llama 70B is on par with GPT-4 for summarization tasks, and it's also on par when it comes to the generation stage of retrieval augmented generation. So that final synthesis stage, when you have all of the data and you're trying to turn it into a concise summary for the user to understand. So here's a little secret. I mentioned earlier that we use 95% of what you saw in that Ray Assistant demo. So Ray Assistant, to remind you, is that button that you press on docs.ray.io that you can do right now. Just open your phone and try it. It's 95% open source. But believe it or not, the last 5% goes to GPT-4. Because ultimately, we believe that GPT-4 can produce better answers for some questions. But when we ran it, what we found is that that's about 5% of queries. 95% of the queries are easy queries that we can hand over to Llama 270B. For evaluations, again, when we were building the Ray Assistant, whenever we wanted to do an evaluation, like is this result better or this result better, or like on a scale of 1 to 5, how would you rate this answer versus this answer? We would use GPT-4 because it was absolutely the right tool for the job, right? But again, look at the math, right? So let's say we send 5% of our traffic to GPT-4. That increases, remember I had that chart before that said that GPT-4 would cost $35,000 and Llama 270B for the task would cost $900. Just that 5% makes the price 2.5x higher. So it goes from $900 to $2,250. Now, $2,250 is still a very acceptable price to pay, right? Where you basically get the same level of service, but for like 1/15 of the cost. And you still get all the benefits of GPT-4. So hybrids are a very real effective thing. Now you might ask, how do you decide which queries go to GPT-4, and how do you decide which queries go to Llama 270B? And the answer is, we use an LLM. It's always going to be the answer, right? So it's a very carefully fine-tuned LLM that decides which model should go to which. And this idea of using LLMs to make decisions, or multi-stage LLMs, is going to be a pattern that I believe you're going to see more of. And really, again, think back to that idea of like the right tool for the right job. You have a simple task, just use Llama 70B. You have a more complicated task, use Llama 70B. If you have something that's like a human could barely do, okay, maybe we should use GPT-4, right? And then deciding which you should do dynamically. So here's another area. So we talked about quality as one weakness, and then we just talked about like it doesn't have to be, you don't have to be didactic. You don't have to kind of force things through. This is one thing I've learned the hard way from practice, which is, it's going to sound weird, proprietary LLMs are more obedient. When you tell them to do something, they actually do it. My hypothesis for this is that, as you know, GPT-4, one of the amazing things about it, if you look at the history of ChatGPT, there was a paper before it called Instruct GPT. And they talk about a process that they have there called reinforcement learning through human feedback. And that's where they look at the output, they have humans score the output, and they basically make it so that what GPT-4 generates, humans like more. And if you're ever wondering like how OpenAI does this, they have teams of thousands in Kenya that are manually labeling the output of GPT-4 to make sure it gets better every time, right? At least that's what's being reported in the media. So my hypothesis is that the open source systems don't have the same level of human review and the same research that's been done into reinforcement learning through human feedback. So here's an example just to kind of show you how crazy this gets, right? So remember that task I showed you earlier? There's a sentence or there's a paragraph, and then there are two summaries, one of which is correct and one of which is not. When you actually go and ask the LLMs, please just give me A or B. I just want A or B. What happens? Exactly what you expect. GPT-4 just gives you the A. At worst, it says answer : A. So you can write a regular expression to process the output of GPT-4. You ask Llama 7TB, and it writes an essay for you, right? Like explaining its reasoning. And remember, I told it just give me an A or a B, but it still did this, right? Also notice that this is costing a lot of money because the A is 1 token, and that's what, 200 tokens? So this has actually evened out the problem, right? Like it's almost made GPT-4 cheaper than, not quite, but made it cheaper than the first one, right? So I'm going to give you a guess how we solved this problem. Does anybody want to guess how we solved this problem? Another LLM. Is that what you're going to say? Few-shot prompting, we tried that actually, it didn't work as well as we had hoped. So we made another LLM, and this one was a Llama 7B model, which this time it did listen, and you just said, you are a helpful assistant that carefully follows instructions. Read this text that was generated by another LLM and decide if that first LLM said A or B. This one actually worked well. It had something close to 100% accuracy. So that one is a very cool thing. So from this, one principle I want you to walk away from is LLMs work better when you ask them to do one thing. Ask it to decide whether A or B is the correct answer, and then ask it to summarize its own answer. That will work better, and the LLMs will generally work better. Now, you could say, with GPT-4, we don't have to do anything about like that. You can just use GPT-4, and it'll get the right answer. So this is a pattern. Often, open source models will need a little bit more work. You have to run a post-processing step, that's another LLM, on the open source model. But it still turns out to be cheaper, and considerably cheaper, right? So we've talked now about quality, about instruction following. The last one is there's a feature that is present in in proprietary LLMs that is not yet available in open source. So, and that is function templates. So one of the engineers on our team, the person who built Anyscale Doctor, remember Anyscale Doctor from the first keynote? The button you press in Jupyter Notebook to kind of automatic. He said the hardest thing for me to, he was using GPT-4 to build the prototypes. And then we said, well, could you use open source? And he goes, man, I really miss those function templates. Because what they do is they lock in the format. You don't have to do any kind of correction. And you can basically say, here's the function template. I want you to output this. So imagine that the task we're getting is we're trying to convert natural language request for a flight information into something that looks like a JSON call, right? And there's two methods. There's city code and there's find flights. And you gave this to Llama 13B, and it just says Boston, San Francisco, blah, 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 blah. So there are 3 problems in this small number of examples, right? The first two, the quotes should have been, they should have been in quotes, and it won't parse. The second one is it didn't use the city codes, so it should have said city code Boston, and then it decided that 6 p.m. was the evening, somewhat arbitrarily, right? Versus something like OpenAI, where you get to define the exact format, and OpenAI will do lots of things for you. It can say, I will selectively use whatever function you want me to use. And so you just declare ahead of time the format that you want, and sure enough, in OpenAI, works beautifully. First time, no fine-tuning required, no clever prompting required, just works out of the box, right? And then the final one is large context windows. So LLMs have this idea of a context window, the maximum size of input that they can take. And one of the problems, again, think back to Goku and Philip's demo of the assistant that we saw yesterday. It's a really great blog post. I highly recommend their blog post about, like, if you want to know anything about RAG, it is a 45-minute read, so it's a lot of work, but it has more detail that you want. But what I've taken is an excerpt from that, where they say, when you're running RAG, you have to decide how many outputs from the vector database to return. And what they saw is when you go from 1 to 2, it gets better, up to 3 gets better, up to 4 gets better, 5 gets better, 6 gets better, 7 gets better, and the Llama says, no, you've exceeded the context window. and you can't test 8 return values, right? So they come up with this thing that says there's a compelling reason to invest in extending context size. And here's where we stand at the moment, right? Anthropic has an industry-leading 100K context window. GPT-4 has 2 sizes with different prices. So you can do 32K or 8K. Llama 2 is 4K, and then Code Llama, interestingly, is 16K. And Code Llama is actually very good at natural language. So if someone came to me today and said, I want to experiment with bigger context windows, I would actually say, believe it or not, go play with Code Llama and see if it works. So OSS is obviously being acted on, but this gives you an idea of something that they're behind. And so I want to just, as we come towards the end of this talk and saying, when do open source models make sense? Quality, I think what we're going to see in terms of quality is there'll be larger and larger open models. We also mentioned, we talked about Falcon 180B. But the other thing to think about is it's not just about model size, and neither is this like a static goal. So there are rumors, for example, that Google has a system called Gemini that they're very close to making available that is considerably better than GPT-4. So I think there will always be a gap. It will always be that, some organization somewhere has way too much GPU resources, doesn't know what to do with it, and I'm going to use it to build a model. Instruction following, there too, I am not expecting to see a huge improvement, but I would like to see one. The ones that I think will be solved in the near future are expanded context windows and function templates. Those are things that will probably get solved in the next 6 months at most. And there's already open source projects for each of these. And in fact, Percy Liang, who was here yesterday, gave a talk, and he mentioned Hyena. It turns out that context window size is quadratic, but they found a sub-quadratic algorithm for doing context window sizes. So once again, I'm just going to promote the best place to run open LLMs is endpoints.anyscale.com. And for anybody who signs up today using this QR code, or just goes to endpoints.anyscale.com, you will get $50 credit for Anyscale endpoints. So that's enough to serve 300 million tokens if you use Llama 7B, or 50 million tokens if you use Llama 70B, right? So yeah, take advantage of it. It's a really clean API. It's OpenAI compatible, so all you have to do is change a few environment variables and model names, and you can use it. So let me just summarize what I have to say in my remaining 1 minute and 20 seconds. What we see is open models are viable in production. People are using them already. In some cases, you can solve particular problems with proprietary LLMs. Small fine-tuned models generally outperform, but only in some cases. Remember to use RAG for factual information. Open models are not just a bit cheaper. They can be radically cheaper, like change the feasibility cheaper. And it takes a bit of extra work in general to use open source LLMs. And they are missing some key features, but they're being worked on. And thank you. That's my email address up there. I'll be up here if you want to answer any questions. Thank you so much for listening to me.